Hello students, my name is Alok Simwal and in today's lecture I am going to discuss about instrumentation of fluorimetry. Instrument used in fluorimetry is fluorimeter. Fluorimeter is a device used to measure parameters of visible spectrum fluorescence. These parameters are used to identify the presence and amount of specific molecules in a medium. Fluorimeter is composed of various important parts. These parts are source of light, filters and monochromators, sample cells, and detectors. First part is source of light. Source of light is used to produce desired wavelength of radiation. Different light sources used in fluorimeter are mercury vapor lamp, xenon arc lamp, and tungsten lamp. First of all, mercury vapor lamp. Mercury vapor lamp is a gas discharge lamp that uses an electric arc through vaporized mercury to produce light. This arc discharge is within a small fused quartz arc tube mounted with large borosilicate glass bulb. In this picture, you can see a mercury vapor lamp. Mercury vapor at high pressure gives intense line on continuous background above 350 nanometer, while low pressure mercury vapor gives an additional line at 254 nanometer. It is used in filter fluorimeter. Continuous spectrum is a combination of wavelengths with no gap within. If any light source produces continuous spectrum, it is said to be a good light source. Next type of lamp is xenon arc lamp. Xenon arc lamp is a highly specialized type of gas discharge lamp in which electric light produces through passing of electricity through xenon at high pressure. In this lamp, ionized xenon is filled within a glass enclosed cell. Xenon arc lamp produces intense radiation than mercury vapor lamp. Spectrum is continuous over the range between 250 to 600 nanometer. Peak intensity is about 470 nanometer. Tungsten lamp. This lamp is also known as incandescent lamp or bulb. Tungsten lamp contains tungsten filament inside a light bulb which can reach temperature as high as 4500 degree Fahrenheit. If excitation has to be done in visible region, this can be used. It is used in low-cost instruments. Next types of parts used in fluorimeter are filters and monochromators. Filters. Filters used in fluorimeter are optical filters. These optical filters works on the principle of absorption of unwanted light and transmitting the required wavelength of light. In inexpensive instrument, primary filter and secondary filters are used to select the desired wavelength of radiation. Primary filter absorbs visible radiation and transmit ultraviolet radiation, while the secondary filter absorbs UV radiation and transmit visible radiation. Next is monochromators. Monochromators are used to convert polychromatic light into monochromatic light. They can isolate a specific range of wavelength or a particular wavelength of radiation from a source. There are two types of monochromator used in fluorimeter: excitation monochromator and emission monochromator. In this picture, you can see excitation monochromator is used just before the sample cell, while the emission monochromator used after the sample cell. Excitation monochromator converts polychromatic light obtained from light source to monochromatic light. In this case, only one wavelength can pass at one time. This monochromator produces excitation wavelength. When this excitation wavelength is incident upon the sample, sample produces luminescence. Luminescence contains many wavelengths. Emission monochromator allows only one emission wavelength at one time to pass through it. It isolates the radiation emitted by the fluorescent molecules. Next part used in fluorimeter is sample cell. Majority of fluorescence assays are carried out in solution. That's why sample cell are designed to hold the liquid sample. Sample cell used in fluorimeter are cuvettes. These are made up of quartz and silica. Cuvettes are designed in various shapes, for example, cylindrical and rectangular. Width of the cuvette denotes path length. Path length is usually 10 mm or 1 cm. Last important part of the instrument is detector. Various detectors used in fluorimeter are barrier layer cell, photomultiplier tube, and photovoltaic cell.
As the name suggests, photomultiplier detector works on the fundamental of multiplication of photoelectrons. The principle employed in this detector is multiplication of photoelectrons by secondary emission of electrons. This multiplication of photoelectrons results in increase in the signal strength. Now in these pictures you can see the construction of photomultiplier detector. It consists of a vacuum tube, a primary photoemissive cathode, eight to 10 diodes, and collector electrode. The primary photoemissive cathode is photosensitive. Different diodes are positively charged. These diodes are charged with increasing potential of 75 to 100 volt higher than preceding one. Now last one is the collector electrode, which collects the electron. When the radiation coming from the sample strikes the first photoemissive cathode, it results in generation of electrons. These electrons are attracted by the diodes, which are fixed each with increasing potential. So the electron strikes the first diode, which causes multiplication of electrons. Then these are attracted by the different diodes, which causes further multiplication. At last, these multiplied electrons are collected by the collected electrode, and the signal produced by these electrons is the fingerprint of analysis of the sample under investigation. Photomultipliers are extremely sensitive to light and is best suited when weaker or low radiation is received. Because of the multiplication process, they increases the signal strength. Barrier layer cell is also known as photovoltaic cell. This is the picture of barrier layer cell. In this picture you can see it consists of a semiconductor, selenium. This yellow portion denotes the selenium semiconductor. Selenium is deposited on a strong metal base such as iron. This red portion denotes the iron metal base. Now a very thin layer of silver and gold is spread over the surface of semiconductor. This is the thin layer of silver. It acts as an second collector electrode. Now when the radiation coming from the sample falls upon this thin layer of silver or gold, it generates electrons. Electrons are attracted towards the iron surface because it is maintained at positive potential. But this selenium semiconductor stops the transport of electrons towards the iron surface. This causes accumulation of electrons on thin layer of silver. It produces the voltage difference between silver surface and base of the cell. Photocurrent is flow which is directly proportional to the intensity of incident radiation beam. Barrier layer cells are also very sensitive in nature. I will discuss types of fluorimeters in next class. Thank you.